Hello everyone, and welcome back to my series of videos on HL Math. Today we will be tackling question 4, which is actually a three-parter, so let's get into it. Consider the functions f of x equals negative x minus h squared plus 2k, and g of x equals e to the x minus 2 plus k, where h and k are real numbers, so h and k are constants in other words. Part A is to find f derivative of x. So that's easy enough. Let's go ahead and do that. So let me first write down what f of x was. And now we're going to find f primed of x. So f primed of x is equal to, here there's the implicit chain rule because of the x minus h squared, but here we're going to use power rule. So if we take the derivative of this, then we get negative 2 times x minus h. And that's what we should get for f derivative of x. And here there's also an implicit chain rule, because we're technically multiplying by 1, because the derivative of x is 1. But technically, we don't have to write the 1, so it just becomes negative 2 times x minus h. Okay, now the question states that the graphs of f and g have a common tangent at x equals 3. So what exactly does that mean? Well, let me draw a quick sketch to show you. So ignore how bad that graph is, but if we look at this graph, we can see that there's kind of two things that are given to us in the question. And first of all, it's that, well, pretend these two graphs are actually touching, but I guess they are. So at this point, the slopes of those two graphs are exactly the same at that point. Why? Because they share a common tangent. And because this tangent is touching both of those graphs, it must mean that the derivative is the same at both points. It's the same at that point. Now, there's a second piece of information that we are also given, and it's that those two graphs intersect at that point. So if you look closely, you can see that this, I guess I should give them names. So x squared and sine x plus 3. These two graphs actually intersect at that point. So well, how is this useful information? Well, we can use it to solve parts B and C. And for part B, I'm going to use the fact that the slopes of those two functions at that point is the same. In other words, the derivative is the same. So let's go ahead and section this off. This is part B. So and because we already know f of x, or f derivative of x, then all we need to do is find g derivative of x. So g primed of x is equal to, well, any exponential function if you take the derivative of it, it just becomes itself. Unless there's a function inside, which then you have to apply chain rule. So here there's also implicit chain rule, but I'm just going to write down e to the x plus, or e to the x minus 2. And if you're wondering where the k's went, the k's are just constants, right? And the slope of a horizontal line is just 0. So now we continue. But we have to be careful here. It's not that the derivatives are equal to each other all the time. They are only equal to each other because there's a common tangent. So here we have to say that f primed at 3 is equal to g primed at 3. So let's go ahead and do that. Let's plug in 3 and solve for h. So negative 2 times 3 minus h is equal to e to the 3 minus 2. We continue, and this is equal to e. It's equal to negative 6 plus 2h. Moving the 6 to the other side, or the minus 6 I should say. This is e plus 6 is equal to 2h, and h is equal to 8e plus 6 over 2. And we have shown that over here that h is equal to e plus 6 over 2. So now the last little part is to show that k is equal to e plus e squared over 4. And to do that, all we have to do is to equate the two original functions to find k. So let's go ahead and do that. And remember, these two functions aren't always equal to each other. They're only equal because there's a common tangent. So again, we have to substitute in the value of x equals 3 into both functions. And here we can also go ahead and sub in the value of h. Yep, e plus 6 over 2. Okay, so now we have negative 3 minus e plus 6 over 2 squared plus 2k is equal to e to the x minus 2 plus k. So now that we have this equation, we can just rearrange for k using algebra. So this negative 3 minus e plus 6 over 2 squared, I'm going to work with the inside first. So I'm going to put this over one fraction. You'll see why in a second. So now the inside 6's will cancel out, and it will just become negative e over 2 squared plus 2k equals e to the x minus 2 plus k. So now we can actually just move the k's to the other side. So we get k and then we can move this term to the other side as well. So we get e to the x minus 2 plus e to the e squared over 4. Oh, and I forgot something. I forgot to sub in the value of 3 for x. So let's just do that really quickly. So k is equal to e plus e squared over 4. And we are done the question. So could you have used the intersection method to show that h is equal to e plus 6 over 2? Well, technically, I guess you could, but it would be more complicated as you have to solve simultaneously. So with that being said, this question is done. And as always, if you have any questions or comments, feel free to leave them in the comment section below. And I hope to see you in the next one.